So in this video, I'm going to kind of do an overview of circle geometry, some review from about circumference, radius, stuff like that. And then we're also going to introduce a couple of concepts about circles that we'll use a little bit in this unit, but will also tie into later units where we talk about rotational motion, and also when we talk about something called simple harmonic motion. So we're dealing in this unit with uniform circular forces or uniform circular motion, right? So let's just look at some basic geometry of the circle, really what you need to know. So a circle halfway or from the center to the edge of the circle is called the radius, and the distance that it takes to go around the outside of the circle is called the circumference. And I know this is all review for you, and in order to calculate circumference, that is 2 pi times r. This equation's on your reference table if you ever forget. And then also in the circle, another idea that's going to be important for us is a line tangent. So a tangent line is one that touches the circle at like one point. So this would be a line that's considered tangent to the circle, right? And that's really all that we need in terms of any basic geometry in order to, apply it to the new physics that we're going to be looking at. So if you notice, I call this uniform circular motion, right? So there are things that are going to remain the same throughout the motion of objects that we're talking about in this unit. And so things that are going to be uniform are that the radius is going to be constant, right? The other thing is we're going to be talking about an object that's actually like moving around in a circle. So the mass is also going to remain constant. Right? And the other thing that remains constant is the velocity. So really like instantaneous velocity or speed, like how fast that object is moving at any point. So if it's going around the circle at 3 meters per second the whole time, the instantaneous velocity is 3 meters per second. All right, we'll come back and talk more about this later, but just remember that this is what the uniform part of uniform circular motion means. Now I'm going to introduce you to a couple of other concepts that we will use a little bit in this unit, but then also, again, like I said, we'll come back when we talk about Unit 7, which is called simple harmonic motion, or it's a unit on periodic motion. And periodic motion just is really the study of anything that is going to repeat a path or a pattern. Right? So circles fall into this category because you're always repeating this path, right? So periodic motion has what is called a period. The period is the time for you to complete your path. So it's the time to complete the path. And in this case, it's really the time to go around the circle once. Right? And because it's a time measurement, it's written with a letter T, right? And the unit is in seconds, right? So the period of a circle is how much time it takes to go around once. Well, what do we call going around a circle once? That's really called, it's the distance it is the circumference, but going around a circle once is called a revolution, right? So a revolution if we're going to talk about like how many revolutions you're going to do in a certain period of time, that's a measurement that's called frequency, which is written with a letter F, right? So this is frequency. I'm running out of room here. Let me kind of move it up a little bit. So this is going to be your frequency, which I'll write that down here. And really frequency is how many revolutions in a time period. So how many revolutions in some time period. And the unit that we use for this could be revolutions per second, or it can also be written as something called hertz, which is written with an HZ, which is really the inverse of time, which is 1 over seconds. All right, and I'll talk about that here in a second, or seconds to the -1. Those are all the same. All right, so this is revolutions per second, so frequency, how many times you go around in a second. So let's say like your frequency is 0.5, right? So if you have 0.5 revolutions in a second, it means it takes you 1 second to go halfway around the circle, right? So these two ideas are really inverse of one another. So if this is seconds and we said this is 1 over seconds, we can actually define period as 1 over the frequency, or frequency as 1 over the period. Another thing that we kind of want to look at in terms of using this concept of both period and frequency is really to get to this idea of velocity. So a lot of this I've kind of just gone through pretty quickly, but really what we're going to use any of these concepts for in this unit is to get to the velocity of the object. This will come back a lot more in terms of calculation when we're in later units, but for right now, just sort of basic conceptual understanding of this will allow us to figure out the velocity that something's going around in a circle. So let me just move to another page and we'll look at that. Okay, so remember 2 pi r is your circumference, and really that's the distance around the outside of the circle. Right? So we know that velocity is distance over time. So if I wanted to calculate how fast something was moving around in this circular path, I would really just need to know, 1, the circumference, so I could do 2 pi r, and divide it by the time it takes to go that distance, which is your period, which we write with a capital letter T. So this is a way of finding the velocity, or the speed that an object is going around in a circle, right? Now, if we look back and we see, okay, well, frequency is actually 1 over t. So we could solve this in terms of frequency too, and we could say 2 pi r times frequency is equal to the velocity. Either one of these will help us to solve for velocity, which then we can use later in the context of our angular acceleration and our forces, which we're going to talk about in the next video.